close your eyes for a moment. Think about everything you have ever seen. The brilliant blue sky, the distant glimmer of a star, the face of someone you love. All of it, every galaxy, every planet, every atom in your body, makes up less than 5% of the entire universe. 5%. That means that over 95% of reality, the very substance that governs the motion of stars and the shape of the cosmos, is utterly and terrifyingly invisible to you. It is a silent, formless presence that surrounds you right now, passing through your hands, your walls, and the very core of our planet, without even slowing down. It is the ghost in the cosmic machine. We call it dark matter. But here is the true horror. If we cannot see it, touch it, or feel it, how do we know this invisible mass exists at all? And what does it mean if the vast majority of our reality is built from something we can never truly perceive? This is not a story about tiny imperfections in our telescopes. This is a terrifying admission that the entire history of human science, our most cherished laws of physics, are built on a foundation of one fundamental cosmic lie. That visible matter is all there is. The stakes are far higher than you think. If we are wrong about dark matter, our understanding of gravity is fundamentally broken. If we are right, then the invisible scaffolding of the universe is made of a completely new exotic type of matter that makes up nearly 85% of the total mass of the cosmos. Which terrifying possibility is the correct one? And what happens when we finally confront the invisible enemy that has been lurking in the shadows since the dawn of time? Before we dive deeper into this mystery, I have a question for you. Imagine you could somehow see dark matter, revealing the true density of the universe around you. Would you find the sight of this invisible, dense network comforting or absolutely horrifying? Drop your thoughts in the comments below. I read every single one, and the most interesting answers might get featured in the next video. And if you are the kind of person who loves cosmic mysteries like this, hit that red subscribe button. Because what I am about to reveal next will change how you see the universe. No, let's go back to the beginning. Our story begins not with a blinding flash of creation, but with a humble but persistent question about galactic rotation, and a brilliant astronomer named Vera Rubin. In the 1970s, the accepted wisdom was simple. A galaxy rotates according to the distribution of its visible mass. Stars far from the center should orbit slower than those near the core, just as planets further from the sun move more slowly. It is basic Newtonian physics. But when Dr. Rubin began meticulously measuring the rotational speeds of stars in the Andromeda Galaxy and others, her team found something impossible. The stars on the outer edges of the spiral galaxies were moving at the exact same breakneck speed as the stars closer to the center. It was like watching a carousel where the outer horses somehow kept pace with the inner ones, defying the laws of motion and gravity as we understood them. The visible mass, all the stars, gas, and dust we could detect, simply did not provide enough gravitational pull to hold those outer stars in their orbits. They should have been flung out into the cold void of intergalactic space millions of years ago. Yet they were not. The implication was staggering. An enormous, unseen mass must be wrapping these galaxies in a massive, invisible embrace, a giant halo of gravitational scaffolding that we could not detect with any telescope or instrument. It was a mystery that demanded an explanation. But what was it? Could it be a hidden population of dim, red dwarf stars or dead stellar remnants like black holes and neutron stars? Astronomers ran the calculations, checking every possibility of normal baryonic matter. But no matter how many invisible stellar corpses or unlit gas clouds they theorized, the numbers still did not add up. They were consistently missing a staggering amount of mass, far more than could be accounted for by known objects. The missing mass was not just a small correction, it was the overwhelming majority of the total galactic mass This mysterious substance had to be 5 times more abundant than all the regular matter in the galaxy, 5 times more mass than all the luminous stars, the great nebulas, and the cosmic dust combined. What does it say about our knowledge of the cosmos when the most dominant component of a galaxy is something that interacts with light so weakly that we cannot even photograph it? By the way, something amazing is happening in the comments section. Last week, one of our viewers asked an incredible question about whether black holes could be the missing dark matter. It is a fantastic thought, but black holes are still made of regular baryonic matter. They are just collapsed remnants. Dark matter is something fundamentally NEW. What do you think? Could there be a type of dark black hole made entirely of dark matter that we are missing? Let me know below. The best comments get pinned. And I might even make a video answering your question. Here's where things get really strange. The key to dark matter is its utter indifference to the electromagnetic force. That is the force responsible for all light, all chemistry, all color, and all visibility. Dark matter does not absorb, reflect, or emit any light or any form of electromagnetic radiation. It is completely transparent, a perfectly invisible substance. Its existence is proven only through one single interaction: gravity. It is the perfect, silent orchestrator of the universe, shaping the cosmos without ever announcing its presence. It has the mass to pull stars and galaxies together. It has the gravity to dictate the structure of the entire universe, but it utterly ignores every other force we have ever studied. It is a profound disconnect that opens up 2 terrifying questions. What if this perfect invisibility means dark matter is merely the tip of a cosmic iceberg, a doorway to another hidden reality? And if it is an entirely new kind of particle, how did such a powerful, pervasive force manage to evade our greatest detectors for so long, and what will happen when we finally make contact? The ghost in the cosmic machine is not merely invisible. It is a gravitational powerhouse that defines the shape of all reality. In the first act, we established the core mystery. The stars in every galaxy are moving far too quickly, demanding an enormous unseen halo of mass to hold them in place. The visible universe, the 5% we can observe, is just a sprinkling of light on an ocean of darkness. But galactic rotation curves were just the first clue. The supporting evidence for dark matter is even more conclusive, and it comes from some of the most violent events in the cosmos. Imagine 2 colossal clusters of galaxies, each containing thousands of individual star systems, colliding at speeds of millions of miles per H-hour. This is the phenomenon we observe in the Bullet Cluster, or officially One-Way 0657-558. This one single observation is perhaps the most powerful, undeniable proof we have that dark matter is real, that it is a separate substance, and that it is not just a glitch in our understanding of gravity. When these 2 clusters smashed together, 2 distinct components separated. The first component was the hot X-ray emitting gas, which constitutes the majority of the regular baryonic mass in the clusters. This gas slammed into itself, creating a shock wave and settling in the center of the collision. But the second component, the mass itself, kept going. Using a technique called gravitational lensing, we can measure the distribution of all the mass, visible and invisible, by observing how it bends the light from galaxies far behind the cluster. The observations showed that the majority of the mass had sailed straight through the collision, completely ignoring the shock wave. This mass had passed through the regular matter, like 2 separate clouds of fog. This is the terrifying deep dive. The gas, the stuff we can see, interacted and slowed down. The dark matter, the 85% of the mass, did not. It proved that dark matter is not just some faint gas cloud, not black holes, and not stellar remnants. It is a separate, non-interacting substance that dominates the universe. If this information blew your mind, hit that like button. It tells YouTube's algorithm to show this video to more curious minds like yours. Together, we're building a community of people who aren't afraid to ask the big questions. And trust me, what I am about to tell you next is even more mind-blowing. The existence of dark matter is no longer a serious debate in astrophysics. The evidence is overwhelming, spanning from the way light bends to the cosmic microwave background radiation. The real terrifying question now is, what is it? The prevailing theory among particle physicists is that dark matter must be made of weakly interacting massive particles, or WIMPs. These hypothetical particles would be massive, possibly 10 to 100 times the mass of a proton. Yet they interact with regular matter only through gravity and the weak nuclear force. WIMPs would be flying through you right now, millions of them passing through your body every second. The only reason we do not notice them is their incredible rarity of interaction. Trying to detect a WIMP is like trying to catch a single grain of sand on a vast beach. In the pitch black using a pair of tweezers. To catch these phantoms, scientists have built detectors deep underground, shielding them from cosmic rays and other noise. Experiments like the Large Underground Xenon Detector, or the Xenon 1-ton experiment, are massive vats of super-pure liquid xenon, designed to wait for the infinitesimally small chance that a WIMP will strike a nucleus of xenon, producing a tiny flash of light. They are listening for the silence to be broken by a single definitive ping that would change physics forever. So far, nothing. The results are stubbornly null. The lack of WIMP detection has led some to ask an unsettling question. Did we spend decades looking for the wrong kind of ghost? The failure to find WIMPs opens the door to another intriguing candidate, one that is far, far stranger, the Axion. Axions would be incredibly light, perhaps 10 to the power of -30 electron volts in mass, making them billions of times lighter than a WIMP. If WIMPs are the heavy, lazy boulders of the dark universe, Axions are the ultralight shimmering threads. Unlike WIMPs, Axions might occasionally convert into light when exposed to a strong magnetic field. The Axion Dark Matter Experiment, or ADMIX, uses powerful magnets and microwave cavities to try and force this conversion, hoping to detect the faintest radio signal from this elusive particle. This approach is highly specific, almost like tuning a radio to an exact frequency, one tiny band at a time. The vast difference between the WIMP and the Axion candidates highlights the truly terrifying nature of this mystery. No dark matter is there, dominating the cosmos, yet we do not know its mass, its charge, or its preferred way of interacting. It could be heavy and rare, or it could be unbelievably light and pervasive, acting more like a field than a particle. This entire search is a testament to the fact that 85% of the mass holding the universe together remains fundamentally unknown. It begs the ultimate question: if both WIMP and Axions fail, does it mean that the universe is made of something so exotic, so beyond our current models, that we might never find it? Or worse, what if the terror is not the matter itself, but our own scientific arrogance? The chilling possibility remains that dark matter is not made of any new particles or action, but that the terrifying truth lies closer to home in a fundamental flaw within our most cherished understanding of the cosmos. Gravity itself, in the second part, explored the indisputable evidence of the bullet cluster and the frustrating search for candidates like weakly interacting massive particles. But the lack of a definitive detection has energized a vocal minority of physicists who argue that we are suffering from a profound case of cosmological confirmation bias. What if there is no dark matter at all? This leads us to the bold, deeply controversial, and yet elegant alternative, modified Newtonian dynamics, MEN, proposed decades ago by the Israeli physicist Mordechai Milgrom. MOND suggests that at extremely low levels of acceleration, such as those experienced by stars on the far edges of a galaxy, Newton's law of gravity breaks down. Instead of needing an invisible halo of mass to explain the fast rotation of those stars, MOND posits that gravity simply becomes stronger, more powerful than predicted by classical physics, when the force is incredibly weak. In essence, MOND is a revision of the gravitational law that accurately predicts the rotation curves of hundreds of galaxies without invoking any mysterious, invisible matter. If MOND is correct, the terrifying truth is not that we have missed 85% of the matter, but that the foundational physics taught in schools, the laws established by Isaac Newton centuries ago, are incomplete. The philosophical implications of MOND are immense. It would mean that a purely mathematical alteration to a fundamental force could solve the most pervasive cosmic mystery. It would elevate the importance of the weak field limit, suggesting that gravity works differently at the galactic scale than it does in our solar system. But MOND itself opens two new, equally profound questions. Can it be successfully integrated with Albert Einstein's theory of general relativity, the framework that governs the very structure of space-time? And if MOND explains the galactic scale, can it also explain the bullet cluster, the ultimate test where dark matter and normal matter clearly separated? What we've covered today is just the beginning of a much bigger story. Next week, I'm releasing a video about the even more mysterious force, dark energy, the substance that is actively ripping the universe apart. The findings, absolutely shocking. Make sure you turn on notifications so you don't miss it. Click that bell icon right now, because the universe still has so many secrets to reveal. The majority of the scientific community still adheres to the dark matter hypothesis, primarily because man struggles to explain observations at the scale of galaxy clusters, like the aforementioned bullet cluster, and its ability to fit into the framework of general relativity is questionable. However, the scientific pursuit of dark matter is a story of incredible technological leaps, driven by the knowledge that we are fundamentally ignorant of the cosmos. Future experiments are moving beyond the search for WIMP and Axions, focusing on detecting the subtle gravitational waves that could be produced by massive dark matter structures, or using incredibly precise atomic clocks to look for tiny shifts in fundamental constants as a particle of dark matter passes through. The James Webb Space Telescope, or simply James Webb, is peering back into the infant universe, observing the initial seeds of structure formation, which are now believed to have been clumps of dark matter. It is a humbling journey. For millennia, humanity assumed its perceptions were adequate to describe reality, built complex philosophies and intricate scientific models based on what we could see. Confront the terrifying realization that everything we know is merely the foam on the cosmic ocean. The vast, dark undercurrent that determines our destiny remains unseen. The quest to find dark matter is, in the end, the search for our own place in the cosmos. It forces us to acknowledge our profound limitations and pushes us to invent new ways of seeing, new laws of physics, and new definitions of existence itself. If dark matter is real, then we are living inside the skeletal remains of the Big Bang, massive, interconnected web of invisible mass that guides every galaxy's movement. It dictates where new stars are born and where old stars die. We are merely passengers on a luminous carousel controlled by an unseen hand. What's your answer to that question? If 85% of reality is fundamentally unknowable through sight, does it change how you value the 5% that you can perceive? Is the seen world more precious because it is so rare, or does the invisible 95% diminish everything we thought we knew? Drop your thoughts in the comments. I can't wait to read them. And if you enjoyed this deep dive into the terrifying truth of dark matter, You'll love my video about the possibility of an infinite multiverse. It explores the idea that our reality is just one of an endless number from a completely different angle. The link is in the description, or you can click the card appearing right now. Until next time, keep looking up.